Very good evening, all of you. Hope you all are doing well. Let's start with today's session. Now, in today's session, we are going to discuss one new topic, that is lambda functions. Same concept is there in other programming languages as well. Like in JavaScript and Java, they call it as arrow functions. Okay, like if in PHP, if you have worked in PHP, they also call lambda function. Okay? Now, what are lambda functions? You can say they are small single line anonymous functions. Anonymous functions means functions which don't have name. Getting? So lambda functions are functions without name. Now these functions can take argument, but they can perform only one single line of code. Okay? Lambda function, 1 minute always. Okay. So we are going to start today with one important topic, that is lambda functions. I said lambda functions are anonymous functions, means they are the functions without name. They take parameters, but generally they perform one single line of code. Okay? Now, what their applications are, that we'll see. But syntactically, how do you write it? In other languages like Java or JavaScript, they call it as arrow functions. Okay, here you have to use keyword lambda. Okay, lambda is the keyword. Then the arguments, whatever you want to pass to it, colon, and then the single line task generally which that function performs. Okay, so whatever task it can be, that is the body of that function. And when you define this function, you can see there is no name to that function. Only the arguments are there. Lambda, the arguments, whatever you're going to pass, and then the body. If it is performing some simple expression, no need to write even return. Just write that expression. That expression will be evaluated and the value will be returned also. No need to mention the return statement as well. Okay? And when this function is defined, you get one function object. Okay, and that function object you can collect here. F is going to be an object, remember, and it is object of class function. It will be an object of class function. Okay, and then you can use this object in which the reference is collected to call it. Means you can just simply write F round bracket and pass the argument. This body will get executed. Getting? Now, actual applications, when you'll see, you'll come to know when we can take the benefit of lambda functions. Okay? But before that, just quickly, I want to tell you that functions are also objects. Getting? Like if you create an integer variable, x equal to 10, and if you check the type of x, you know that it is an object of class int. Is it right? Class int. If you're creating a string, right, and you check the type, it is an object of class str. Means in Python, each and every identifier is an object of some class or the other. Same way, functions are also object of class function. See, therefore, if I'm writing, and it is not doing anything extra, just printing hello world. Okay. Now you can call that function by writing foo round bracket function will get called, no problem. But this function name, if you check this function name, it is also object of class function. Getting? You can check its type of foo. It will print class function. Means it's an object belonging to this class. Like X is an object belonging to integer. Y is an object belonging to class str. Understanding? So same is the case for lambda because it is also function. Only it is a function without name. Now, as it is a function without name, still it is a function. So it will be also holding the reference in object of class function. See, if I write uh, f equal to and lambda x, if it is a one argument function, okay? So I'm just writing lambda x colon, and suppose it is returning square of it, x double star 2. Okay, so actually this much is the lambda function. Lambda is a keyword, no name to the function. Parameter is x, and it is just going to return square of it. No need to write return statement as well. Now the function is not called yet, it is just defined. And the reference of that function we have collected in f. Correct? If you check the type of f, it will be an object of class function. See. With this, it proves lambda functions are also functions only, like normal function. Only they don't have name. Getting? Here we have name. Here there is no name. We can collect its reference. And if you check the reference, it is also object of class function. And now if I write f round bracket 30, it will return square of 30. Get it? Indirectly, what has happened? F of 30 means it's going to call this lambda function. You can create a lambda function with more than one argument also. Okay? X comma y colon. And here suppose I am returning x star y. Okay? So this is a lambda function with how many argument? Two argument. And it is just returning x raised to y. Okay? Now lambda function is defined and its reference is just collected in G. That G is obviously going to be an object of class function. And now if you write G of 5 comma 3, it will return you 5 raised to 3. Or you're writing G of 2 comma 4, it will return 2 raised to 4. Get it? Okay. Now still it may not be much convinced to you why we need lambda function. Now the same activity you can do it by normal function also, guys. X raised to y. Getting? You could have written this way also. Def uh, the name of the function you can give like my POW x comma y colon, and then you'll write return x double star y. That function is also doing the same task, my power, and I'm giving 5 comma 3, the same thing. Get it? But this is more concise. In single line, you're achieving the task. So generally, when your functions are very simple with single line tasks, you can make use of lambda instead of writing the normal traditional functions. Get it? Now, usually where these lambda functions can be used, I'll tell you that, don't worry. Before that, just the basic definition we will understand. Remember here also this my power is going to be what? Object of class, just now I told, function. Get it? See, class function. See. So a lambda function is a small anonymous function. Anonymous means what? I hope you know it. Anonymous is a English term to represent without any name. I think in colleges till 12th, if you have one subject of literature, one chapter used to be always there of anonymous author. In English, like generally one chapter, and in that they generally don't write who has written. They used to mention anonymous author. Anonymous meaning without name. Correct? Generally, people give donation to temples or whatever. So that time also they don't want to reveal. So it is mentioned as anonymous donation. Correct? So a lambda function is a small anonymous function. It's a function without name. Lambda function can take any number of arguments, but generally the body of that lambda function is simple single line code, but can only have one expression. Actually, you can write any big code, but then if you're going to write big code, then don't write lambda, go for normal functions only. Correct? It's allowed. So generally, lambda is to be used where within the body you're going to write very simple task. Okay? See, general syntax is like this: lambda, then the arguments, colon, and then whatever task that function is going to do. If this function is performing some calculation, no need to even write return. Get it? No need of using return keyword. It is going to return the value. Okay. The expression is executed. This expression will be executed on these arguments and the result is returned. Get it? But when you call this lambda, now to call this, you have to collect the reference of that lambda. This lambda function will be defined somewhere. It will return the reference. Collect that reference. See here, in this example I have done. I defined that lambda and then I have collected that reference in F. And now using that F, I'm giving a call to it. See, F of 30. So it is calling this lambda. In X 30 is coming, 30 square, 900 it is returning. We didn't even wrote return. Still it is returning that value. Okay. And remember, lambda is keyword. As an example, I'm giving, this is a one argument lambda function. See, lambda x, it is just doubling that value, x into 2. Again, just a simple example. Generally, you should give simple illustrations only when you are explaining some concept. So lambda x, x into 2. Now that lambda is defined. Okay, yet it is not called. It is just defined. And after definition, you get the reference of that function, which you're collecting in F. This function also will be stored somewhere in the memory. So where it is stored in the memory, its reference we are collecting in F. And now using that reference, we are giving call to that function. See, F of 5. F of 5, when I say 5 will come in X, 5 into 2, 10. F of 5 plus 6. First 5 plus 6 is evaluated. That is 11. And then that 11 is passed here. Get it? 5 plus 6, 11 is passed here. And 11 into 2, 22. It is not going to pass 5 plus 6 as it is. 5 plus 6 as it is not passing. 5 plus 6. Otherwise, the answer will be different, guys. If it is passing 5 plus 6 as it is and 5 plus 6 into 2, then the answer will be different. 6 into 2, 12 plus 5, 7. No, first it evaluates that 5 plus 6, 11. 11 passed, 11 into 2, 22. Same, you can write a lambda function with two arguments also. See, this is a lambda function which is taking two arguments, okay, and returning the addition of it, a plus b. Okay, now lambda function is defined and its reference is collected in G. You have defined the lambda function with two arguments. It is performing just addition. Reference you got in G. Now using that G, you're giving the call to it. G of 5 plus 6. So 5 will come in A, 6 will go in B, then 5 plus 6, 11. That answer is returned, that is printed here. Okay? Quick applications I'll tell you, and then we will see it practically. Okay? Few applications I'll show you where we can make use of lambda function. Okay? First is whenever you need any function just for one-time use, throwaway functions we call. Means I want to define a function in which some logic is there, but that logic is needed just for some task. Once the task is achieved, I don't need that function. It is not needed for reusability. Again, many places I don't need it. I need that function just to achieve some other task. Correct? Once the task is achieved, I don't need that function. That time, lambda will be very much useful. A throwaway function. Because anyway, they are anonymous. They don't have name. So directly you can pass that function to some other function. Other function will use it. Once that other function is over, that function is lost. Correct? So one time use, that time it is useful, also known as throwaway function, as they are needed just once. Then lambda can be used when you want to pass function as an argument or return function as an argument. Correct? There also you can make use of lambda. I'll little bit try to explain it. Okay. In Python, it is allowed to pass one function as an argument to another function. Correct? I'll just try to explain it. Okay. It's called as a higher order function. Or I'll just give. Okay. Func2 dot py. Okay. What Python rule is, Python says when you're passing some parameter to function. So you can pass any type of parameter. Can I pass integer? Can I pass string? Can I pass float? Can I pass string? Yes or no? Can I pass a dictionary? Can I pass a tuple? We have seen, like till yesterday, we have seen somewhere we were passing a list as an argument. We were passing a tuple also. We were passing a dictionary. So Python says when you can pass different type of objects as an argument to function, why can't you pass a function only as an argument? Because function is also a object. Understanding? Clear? Like, suppose I've defined one function def foo, and to that I'm passing some argument x, and it is just going to return x star. Okay, this is one function. And I'm writing another function bar to which I'm passing f as a argument. Okay, now we'll say what is that f? Like here we know x is going to be an integer. But here this f is a function object. Getting? Means what my question is that, my explanation is, when you write a function, are we allowed to pass any type of object as an argument? Python says you can pass integers, you can pass float, you can pass strings, you can pass a list, you can pass a tuple, you can pass a dictionary. Then why can't we pass a function only as an argument? Because function is also a object. Just now we have seen. See, we defined the function, we collected the reference, and then we checked what is the type of it. It is an object of class function. So can we pass a function only as an argument? Yes. Okay. So here in bar, what we have passed? F. Okay. And what that F is doing? Returning F of 10, or suppose that value also I'm passing here as Y, and it is returning F of Y plus 100, suppose something like that. Okay. So you can observe here, you're passing one function object only as an argument to another function. Understanding? Now I'm going to call bar. Then I'll pass foo comma 10. Means what is done? Can you study this carefully? You're calling bar and you're passing argument as a function object only. Is the name of a function object? Today only I showed you. See, we defined one function foo, and then we checked the type of foo. Is foo also object of class function, guys?
Yes.
Get it? So what I'm passing I'm passing the function object only as argument. As you
Yes.
can pass an integer, you can pass a float, you can pass a string, right or no? You can pass a list, you can pass a tuple, you can pass a dictionary. Same way they say you can pass a function object also. So I am passing this whole function object only here. And next is an integer. So when bar is called, the reference of foo is passed here. So in F, actually what is going to come? Whose reference only?
Foo function.
Foo function, right? You got it. So in F, the reference of foo only is going to come. So when you are writing f of y, is it same as foo of y?
Yes.
And what is y? 10. Y is 10. So foo of 10. Foo of 10 means 10 square. Foo of 10. 10 will come in
And
x. Get it? And then 10 square 100 and plus 100, 200. It will return 200. And you can print and see. Okay. Here, what I just wanted to show that you can pass one function reference as an argument to another function. As you can pass an integer object, you can pass a list object, you can pass a dictionary, you can pass a string. Same way you can pass a function object also as an argument. Getting guys? When I wrote
yes.
bar foo 10, I am passing the reference of foo. Foo is not called, only the reference is passed, which will come in F. What will F contain now? Foo's reference. So using that reference, I'm giving a call to function. F of y means foo of y. That y will go in X. What is y? 10. So foo of 10, 10 square 100, 100 plus 100, 200. This bar will return. And what that bar is returning, that we are printing. ठीक है? See here. Python func2. Is it returning 200?
Yes.
Okay. I hope it is clear. This concept is clear. In this, some terminologies are there. A function, okay, to which some other function reference is passed. Get it? That function reference is called as a first class object. Remember, first class object means what? Reference of a function passed to other function. Whenever you're passing a reference of a function to some other function, that reference is called as a first class object. Please remember. And the function which is receiving first class object as an argument is called as a higher order function. Okay. Who is a higher order function? Function receiving, okay, function receiving what? First class object as argument. Getting? A function which is receiving first class object as argument is called as which function? Higher order function. So in this case, can you tell me who is a first class object and who is a higher order function in this example? You can identify and tell me who is the first class object.
Foo.
Foo, or you can say F, one and the same thing. Foo you're
Yes.
passing, which is coming in F. So that F is the argument, which is a function reference and a reference of a
Yes.
function passed to other function. So you can take foo also or F. It is a first class object. And who is the higher order function?
Bar.
Because it is receiving a first class object. A function which is receiving a first class object as argument is called as a higher order function. So here, who is the higher order function? Bar. Getting? Now you may say like, is he not diverting it from lambda? He was telling something about lambda, then suddenly he's talking about this. I'm coming to that. Okay? You know, some people, in short, like Gen Z, especially Gen Z लोगों को जल्द से जल्द फटाफट आंसर चाहिए. They don't have patience to listen. They don't have patience to analyze. They don't have patience to take the uh, decisions, conclusions. They don't have patience to go in the past and study the history. Nothing. They want quick answer. And then problems arise. Yes or no? Okay. So I'm not blaming Gen Z. My daughter is also Gen Z. Okay. So not to you people only I'm blaming. So they want quick thing. So I'm coming gradually to it because some people might have started thinking like he was telling about lambda and then suddenly he's telling this. Why? Because I was telling about this second application, that is input output of other function, meaning you can define a function, to which you are passing sec some other function's reference. Correct? When you're passing some other function object as an argument to another function, there also how we can make use of lambda. Okay? So concept, I hope you got it. So what does Python allow? That is clear to you. Python says you can define a function to which you can pass argument, and that argument can be of any type. You can pass argument as integer. You can pass argument as string. You can pass argument as list. Why can't we pass an argument as function object, which is allowed? See, when you're passing foo, means you're passing a function object. It is an object of class function. You're collecting in f. Now, can I convert this into a lambda function? Instead of defining foo, okay, instead of defining that foo, I'm cutting it. And here only I'm defining a lambda function. See, lambda x colon x double star 2. Is this lambda doing the same work of that foo?
Yes.
Get it? Is this lambda doing same work of foo? It is taking one integer and returning the square of it. So see what has happened. There only you are defining. Means indirectly here I'm showing that first application also. One time use or throw away. That's what happening here. Once that bar is done, this function is thrown. It is not reutilized. Okay, but anyway, that application separate. Here I just wanted to show you can pass lambda. Return also. I'll show you about return example also. Okay. So this concept, I hope it is clear. See, can I define lambda over here only? Is the lambda defined? It is a one argument lambda, returning square of it, only defined. It is not called. And the reference of that lambda. But tell me, is the reference of lambda also a function object only?
Yes.
Means your normal function is a function object. Lambda is also a function object only. So what is happening? Your lambda function is defined and the reference of that lambda is passed to f. So f is collecting the reference of this lambda. And inside when you're writing f of y, it is same as this lambda only. Is this lambda only getting executed here? Getting? So what is y passed? 10. So 10 will be given here. 10 square, 100, 100 plus 100, 200. So still you'll get the same output, guys. Correct? You can check here. Is it returning 200 only?
Yes.
Okay? Okay. So here you got the concept that whenever you need to pass a function as an argument, that time also you can make use of lambda. And returning also, from inside you can return function also. Getting that concept also I'll try to tell you that Python says function 3.py, I'll do it. Okay. Python is saying that if you define a function, so from that function inside, you can return an integer. Can you return a list? Can you return a string? So Python says you can return a function object also. Get it? It's allowed. See here. I'm defining one function. I'll call it as outer, to which I'm passing some value, outer x. Now, Python allows you to define one function inside another also, which generally static type languages don't give. Like Java or if you consider C, they don't allow you to define one function inside another. They allow you to call one function inside another. Defining is not possible. Here you can define. See, you're defining one more function inner, get it? And with parameter y, and assume it is returning y plus x. Means it can access the value of that outer function. It can access the value of that whatever you're passing to outer, that it can access. Okay. Now, suppose you're saying like, I want to access this inner outside outer, not directly possible. Understanding? Okay. And you may say like, what does this outer return? Okay. So it is going to return inner. Direct inner you cannot access outside outer. But first basic concept, what you saw here, that you can define one function inside another function. You have just defined it, one function inside another. Inner cannot be called outside outer directly. Correct? Outer you can call directly. Okay? But inner you cannot directly. You can return it. Okay? So I'm returning that reference. Return, okay, inner like this is allowed. You can return inner. Okay? Okay. If you don't want to do it with parameters, you can just check it without parameter. What we'll do is in every statement, here I'll just print I am in inner. Okay? And here we are giving message print I am in outer. Right? And suppose you call outer. You're calling outer. So when you call outer, it will go to outer, and in outer there is only one line. This is the definition. It is not called yet. It is not called yet. It will just display I am in outer. If you want, you can call that inner here. Inside outer, you can call it here. Okay? You're calling it. So when outer is called, it goes there. Then it calls inner. So it goes to inner. I am in inner, inner over, I am in outer. That way two statement will come. Correct? Python function 3, suppose. Both the statement are coming. You have called outer, goes to outer. Now in outer, what is the first statement? Call to inner. It will go to inner. I am in inner. Complete. I am in outer. Getting? But now you will say outside outer. If I want to give the call to inner, can I call? If I want to give the call to inner, can I call directly inner here? No, guys. When you try to call, see, already it is giving an error. It is saying inner is not defined because it is defined inside outer. So how you can call that inner outside outer? By returning it. See, can you return inner? Is it also object, guys? Is this inner also a
Yes.
function? So as it's a function, it is also object. Can I return that object, that inner function object? It's a function object. See here, now can I collect it like this? F equal to outer. Okay, so it will go to outer. In outer, the first thing is call to inner. This is just the definition, guys. So call to inner, it will go to inner. I am in inner, then I am in outer, and then it will return the reference of that inner, which you are collecting in F. And now if you write F round bracket, okay, F round bracket. So what function will actually get called? What is collected in F?
Outer.
Inner function.
You got it, means the concept is clear that in F, whose reference is collected? Inner function. So when you are writing F round bracket, means indirectly that inner is only called. Get it? Now, again, some people may have a doubt like, why do we write inner functions? Again, they are functions which are needed only in some other function. Like if you have one function and inside that only we need that task. Throughout the code, I don't need that. Means in throughout code, I don't want to do reusability of this function. I need this function only to achieve that outer function work. Outer function work is to be achieved. So for that, I have written. I don't need this anywhere again. Then instead of defining outside, write it locally only. Okay. Now when you call F round bracket, is it going to call that inner only? Check here. See, is inner getting called twice? Once inner got called inside outer, and once when you collected the reference, when you're collecting the reference, that time. Get it? Now, here also, instead of defining it inside and then returning, can I return a lambda only directly? Suppose what I'm doing is, instead of defining it like this, can I return one lambda function only here? Okay, see, I'll write I am in outer and then returning lambda, no argument, okay, and just printing I am in inner. That's all. Okay. Now tell me what will happen. Means indirectly I'm returning what? A inner function only. But that inner function is a lambda function. And F round bracket. Okay. So when I run this, first it will give call to outer. In outer, I am in outer. And then you are defining one function. It is a lambda function with no argument. You are just defining, and then the reference of that function you are returning, which you are collecting in F. So when you write F round bracket, is it actually going to call this lambda only? Yes or no, guys?
Yes.
Getting? See, you can check. I am in outer, that has come. Then you defined one lambda. That lambda's reference you are returning. That reference is collected in F. And when you write F round bracket, means indirectly that lambda is only called. Correct? So here I wanted to show that you can pass or you can return functions. You can pass a function as an argument, or you can return a function. Correct? So that time also, when you're passing a function, you can pass directly a lambda. While returning, when you are returning a function, you can directly return a lambda. Correct? That is our second application. Okay, we are going to learn this one in more detail, the first one, by taking some examples. Okay, I'll take some concepts like filter, map, reduce. Okay, in that, how we can make use of lambda, I'll show you. Okay, so IO of input output of other function. So passed as input or returned as output from other higher order function. I hope you have understood about first class object and higher order function. What are higher order functions?
A function receiving first class object.
Very good. A function receiving first class object is called as a higher order function. And what is a first class object? Object which is containing functions reference. The object which is containing some functions reference. Getting? Those who have learned C++, they should know it's called as a function pointer. Here it is just a function object. So see here that F is a first class object and that first class object is passed to bar, therefore bar is a higher order function. So these are all terminologies you should know. Generally these are taught in colleges only. Those who do engineering, MCA, MCS and all, they generally have one subject called Principles of Programming Paradigms. In that, it is usually all these things are taught. And one obvious thing you might have observed because of lambda is the code size getting reduced to single line. The
Yes.
same single line function, if you're defining it with a normal one, then also you have to write that def keyword, then the name of the function, round bracket, parameter, colon, then come on the next line and then write the body. Instead of that, this lambda gets reduced to just single line. Get it? The body of lambda function is returned in single line. That is the benefit. Okay. Now what we'll do is we'll take some applications of lambda, how lambda can be used. Okay. In that, the first application is filter function. Filter is a function provided by Python only. It is a inbuilt function. And using this, how we are promoting a declarative coding or functional programming. Functional programming, or you can call it as declarative. Functional programming and procedural programming is different, guys. Procedural programming means dividing the problem into smaller problem, then write a procedure for every function, and then, sorry, for every subtask, write a procedure, and then call that procedure somewhere in the main code. That is procedure-oriented code. Functional coding is something different. Functional coding means they say uh, reduce the lengthy logics and hand over that to someone else. Means someone else is going to do that traditional logic for you. You are just going to tell what to do. You are not bothered about how. Understanding? It is more towards declarative coding. Declarative means you're understanding. Declarative means you just tell what, not bothered about how. Imperative languages, what and how, both our job. What to do and how to. How means the algorithm. We have to write. So functional programming are trying to hide the traditional logics because that logic someone else is going to do. You will just try to instruct what to do. Getting? I'll show you how we can do it with this. Getting? So functional programming is basically based on that. Functional programming is mostly towards the declarative side. It is saying avoid writing the legacy logics. Legacy means you're understanding the traditional, which you cannot avoid also. You have to write it. Parampara, we say years and years it's going on. But there's no option. You have to write those logics. So what this declarative coding is saying, that traditional logics, that legacy logics, same logics you are writing, don't waste your time. We will do it for you. You just instruct us. Get it? Where ultimately in the background, the same code is generated, but that part is getting hidden to the programmer and the efforts of programmer are reduced. Getting? So I'll justify it also. It will be more clear to you. So we are going to see one lambda function, sorry, one built-in function provided by Python called as filter. Okay. Now what this filter does, that I'll tell you. Filter function will take one iterable. That iterable can be anything. Okay? It can be a list, it can be tuple, it can be set, anything. Okay? So it will take one iterable object and one function object. Function object means you're understanding, no? This function object, tell me in the technical term, is it going to be a first class object?
Yes.
So can we call filter as a higher order function?
Yes.
Why? Because filter is receiving a function object. Such functions are also called as callback function, huh, guys. Callback. This terminology is all asked in the interviews, and that time then you will start blaming me. ये कुछ बताया भी नहीं sir ने. Correct? These are the common things asked. So callback functions means functions which programmer define, but programmer doesn't call it. It is getting called implicitly by someone else. Okay, so functions which are defined by the programmer but called implicitly. by some other system again and again. It is getting called again and again. That's the reason we say it is getting called back. Correct? So we are not going to call it. We are just going to define it. हम लोग सिर्फ define करेंगे. Calling someone else is going to do. And how many times? Again and again. Correct? So such functions are called callback function. So when you're passing that first class object, it is sure going to be a callback function because that function is going to get called again and again implicitly by someone else. When I move the mouse, you should get the hint. Like, get it? So
Filter.
filter, then your function and your iterable object. Getting? Now that iterable can be a list, it can be a tuple, it can be a dictionary, whatever it is. Getting? Now what this filter does is it will call this function again and again for each value in the iterable. So see how our logic is getting avoided. What traditional logic we write, how that gets hidden within this filter. And it goes to declarative side instead of imperative. Getting? I'll tell you. So what is this filter going to do? It is going to call this function repeatedly, okay, for each value of your iterable. As many values are there in the iterable. For each value, it will call this function. And this function you can define already by using def and just pass the name. Or here only you can define as lambda. So obviously what we will prefer, defining already and giving name, or here only we will define as lambda.
Well defined as lambda.
Yes, because that is only the application. No? He has applied common sense. उसने common sense लगाया कि obviously sir is taking applications of lambda. ये सब अभी topic under lambda है. तो obviously यहाँ lambda ही pass करना better है. Get it? So instead of defining and then passing the name, better pass here only lambda. So can we say it is one-time use or throwaway function? Just till filter purpose, till the filtering is going on, that function is useful. Once the filter is done, it is thrown, lost. We don't need it again. Only for that filtering task we need. Okay, but it is allowed. It is not mandatory that you have to pass lambda. You can define a function with a def and the name you can pass. When you pass the name, anyway, you're passing a function object only. And if you directly pass a lambda, then also function object only. Get it? So what is this filter going to do? Call this function repeatedly, implicitly. Okay, it is going to call it implicitly again and again for each value of your iterable. Get it? And this function is to be defined in such a way that it should return true or false. Only true or false. Getting? So as many times your function is returning true, only those elements are put into another iterable. It will put those elements in some another iterable. Who that filter is going to do. So filter will call this function for each value of your iterable. And as many times this function returns true, for whichever element it has returned true. If there is element 1, element 2, element 3 going on. So suppose for element 1 false. Okay, to not gone here. Element 2 it is true. It will add in this. 3 also true. It will add here. For element 4 it has returned false. So rejected. So for whichever element the function is returning true, it will put it into one more iterable. And at the end, it will return that iterable. Now you'll say, what is that iterable? It is an iterable of class filter only. Means this filter is also a class. So it is going to return one iterable of class filter. And what will be there in that iterable? Only those elements of your iterable for which the function returned, fill in the blanks,
True.
true. You got it. Get it? So those elements of your iterable, okay, those elements for your iterable for which the function has returned true, Only those are put into that filter object and it will return that filter object. Understanding? And how this whole thing is happening in one line. Don't you think? So I'll try to justify that how this is moving towards the declarative side. Correct? See, without filter, I'll show you filter demo.py. Okay. Suppose someone is telling you that, okay, I'm defining one function is E1 and I'm passing one argument to it. Is E1 and I'm just passing one number to it. And what is this function going to do? Check whether it is E1. Yes, return true, otherwise false. So I'll write return x mod 2 double equal to 0. Okay? I'm dividing that x by 2 and whatever remainder is coming, I'm checking whether that remainder is 0. So if this remainder is exactly equal to 0, it is even. Now I hope you know that basic. When a number is divisible by 2, it is even. Otherwise it is odd. So if I pass 5 mod 2 remainder is 1. Is 1 equal to 0? No, false. If I pass 12 mod 2 is 0. 0 equal to 0? Yes, return true. This is my function. Then someone tells you this is one list of values 23, 68, 79, 112, 100. I forgot to put comma here. Okay, 100 is there, then 24 is there, 12 is there. Okay, 79, 111. Now someone tells you write a logic to filter all the even elements in another list. Okay, someone has told you to write a logic or write a program to copy all the even elements of this list into another list. And if filter is not there, so you will write imperative code. Main thing we are trying to move towards a functional logic. Functional things means what? You just tell what, how someone else will do. Correct? Means the same traditional logics, legacy logics. Why to keep writing? What modern programming is saying, the codes which are coming from years and still they cannot be removed. We need it, still we need it. There is no option. So those codes, you don't waste your time in writing. We will write it for you. And it becomes abstract. We don't know someone else has developed it for us. Correct? So suppose I tell you to filter all the even values. What you will do if filter is not there? The imperative logic means traditional way. You'll create another list, which is an empty list. I'll call it as E. Yes or no, guys? You'll create an empty list. Then you will write a for loop to traverse this list one by one for
Yes.
X in L. Yes or no? You're going to traverse this whole list one by one. One by one element is coming. Can I pass that element to easy1 function? Do you agree, guys? Can I pass it to easy1?
Yes.
If easy1 X, say I'm calling that easy1 and that X I'm passing. Means every time one by one element is coming in X and I'm passing that X to easy1 and whatever easy1 is returning, true or false. So if it returns true, I'm appending that in append function is there for a list. I'm appending it in X,
Yes.
right or no? So you wrote that traditional logic. What you wrote, you are traversing each and every element one by one. Okay? Then each element you are passing it to this function, which is returning true or false. Correct? Then if the function returns true, then you are adding that value in that empty list. And at the end, if you print and see that empty list, it will contain all the even values from this. Okay? Okay? Suppose I'm giving here filter demo. Is it returning all the even values in that list?
Yes.
68, 112, 100. But this filtering work, who has done? We. We wrote the logic of filtering. We wrote the logic of traversing this list. then
Yes.
passing each value to that function. Whenever the function returns true, we added it in the empty list. This whole thing can be hidden if you go to filter. Correct? See how it can get reduced to one line. Okay, I'll show you. See. Now this logic you got, the traditional logic. Now using
Yes.
filter, this logic is getting hidden. Ultimately, the logic is same legacy logic. You cannot avoid it. But this legacy logic, someone else is going to implement it for you. And your programming efforts become less. Get it? See, what I'll do is that, or you can put it into a comment, or I'm removing it. And now I'm calling filter. Okay? To that filter, you have to pass one function object. I'm passing easy1 and comma, I'm passing L. Done. काम खत्म. Don't you think? एक लाइन में काम हो गया. हमारे लिए एक लाइन. For us, it is one line. But that loop which we implemented here now, that who is implementing it for you? Filter.
Filter.
So can you say it is going more towards declarative? You're telling to filter that please
Yes.
filter all the elements from L, and this is the condition. Please apply this condition on each value, and whenever true is coming, please give me only those elements. Will it return that here? So is this a function object? You're passing a function name. When you're passing a function name, means you're passing function object. Is it a first class object? Yes. And who is the higher order function? Filter. Now, what is filter internally going to do? Will it traverse your L one by one?
Yes, sir.
And will it pass each element of your L to easy1?
Yes.
And as many times easy1 returns true, only those elements will it put it into another iterable?
Yes.
Means is that filter inside going to create one empty, then write a for loop, then one by one take the value from L, then pass that value to easy1, as many times true, put it in that empty list, and everything done. At the end, it is returning you that list which you are collecting here. Only the thing is, E is not a list, it is a filter object. But still, it is a iterable only. Yeah? If you try to check the type of it, ठीक है, quickly 2 minutes you give me, ठीक है, type of E. It is a filter object. See, class filter. Okay, so you can convert that filter object to list object if you want to print that whole list. Correct? We could have done, we have done it past, like during tuple. Do you remember? I converted tuple to list, then I
Yes.
added one value, then I converted that list back to tuple. The same
Yes.
way here also, you can convert that filter object to list object. You got it. Now you can check that E. Now E is not going to be a filter object. It is a
Yes.
list object. And directly you can see it. Is it returning in
List.
E only the filtered value? Can you see the code is reduced? From your aspect, it is reduced. Ultimately, in the background, the same code is there. But who has implemented that code for you?
Filter.
Filter. Getting? So is it moving more towards declarative way?
Yes.
Declarative means you're understanding. No? That is, you just tell what to do. You're not telling how someone else is doing. Correct? So who is that someone else? Filter. Can I say easy1 is a callback function?
Yes, sir.
Why? Because we have just defined it. We have not called it. Just now I told callback function means a function which we define, we don't call. Someone else is going to call it implicitly again and again. Getting? Now, can we reduce this still more by instead of writing a function with a name, can I define here only a lambda and reduce these two lines also?
Yes, sir.
Yes. Getting? See, I'll cut this. And what I'll do is I'll write here only a lambda function. Lambda x colon x mod 2 double equal to 0. Kam khatam. See, is the code got still reduced?
Yes.
Getting? But only the thing is such lambdas are throwaway. one-time use. They are needed only for that filtering. Once the filtering is done, it cannot be reused. Correct? But still, you will get the same output. Now, for time being, some more values I'll put. Okay. And quickly you can see this. Is it returning?
Yes.
So I hope you got the application of Lambda now.